Let's start off with the new topic, factors, HCF and LCM. Simpler topic, but application is a lot. So this will be applied in a lot of places. So we will be learning in this particular sequence. Starting off with factors, and there are few things which we'll learn under that. So the first thing is definition of the factor. So factors are integer numbers that can divide the given number with 0 as a remainder, are the factors of that number. Okay, so basically this is your definition. I'll give example and explain. One more way of defining this is, we can also define it as the possible numbers that we multiply to get the number are the factors of the given number. So I have a example over here, 10. Okay, let's find the factors of 10. So how to find the factors of 10? As per the first definition, the integer numbers that can divide the given number with 0 as a remainder are its factors. So which all number can divide 10? Well, 10 is divisible by 1 and 10 itself, because 1 tens are 10, right? 2 5s are 10. So these are the only numbers which is under integers, positive integer, that can divide 10. But yes, there is certainly positive and negative, positive and negative, positive and negative, positive and negative. Basically there are 8 integers, right? When you talk about integers, there are 8 of it which can divide 10. So as per this definition, all of this number can divide 10 with a remainder 0. Make sense? Now, as per the next definition, what we have here is, we can also define it as the possible numbers that we multiply to get the number are the factors of the given number. So, as per the next definition, factors of 10 include 1 into 10 gives me 10, 2 into 3 gives me 6, 2 into 5 gives me 10. So here, as per the definition, this is not a factor. Clearly, that's not a factor, as I'm getting 6, not 10. This set of numbers are factors, and here too I'm getting 10. So this set of numbers are also its factor. Beside this, we can also do this, right? Not plus, minus 1 into minus 10 will give me plus 10, minus 2, minus 5 will give me plus 10 again. So in this way, I have 8 integers that can divide 10. So all those are factors. I'm not talking about prime factors, I'm talking about factors. Prime factor is the next filtered version of factors, and it has its own usage. So we need to learn what is a factor, then prime factor and prime factorization, and then HCF and LCM. So before that, we need to define what are prime numbers. Before we start talking about prime factors, first is prime numbers and composite numbers. So prime numbers are natural numbers that is greater than 1. So where do we start natural numbers? We start natural numbers with 1 to infinity, but since we have one more condition that it has to be greater than 1, so my definition of prime number starts from 2 to infinity. That cannot be made by multiplying other whole number. So basically, I need number which when multiplied with itself and 1 gives me back that number, and no other way. Example, I can't multiply anything else to get back 2. But I certainly can multiply 2 and 2 to get back 4. Along with that, I can multiply 4 into 1 to get back 4. So in that way, 4 is not a prime number. So 3 is 2, because 3 cannot be written other than 3 into 1. We can't write it as anything else. 1 is a prime number. Sorry, not 1. 5 is a prime number. 1 is not a prime number. Okay, 1 is not. So these are all not prime numbers. So 2, 3, 5. If we start writing down till 100, so we'll start with 2, 3, 5, 7, 9, sorry, not 9, 11, 13, 14, 15, 16, 17, 18, 19, 23, right, so on and so forth. Okay, those are all your prime numbers. Next, composite numbers are whole numbers that can be made by multiplying other whole numbers. So basically, non-prime numbers are your composite numbers, but there is an exception. Exception being 1 is neither prime or composite. This knowledge of 1 being neither prime or composite is useful when you go to higher grades, and when you talk about competitive exams, it will be asked directly or indirectly. So this is something which you need to know. 1 is neither prime nor composite. So composite numbers are whole numbers that can be made by multiplying other whole numbers. So basically, example 4. So 4, we can get 4 by multiplying 2 and 2, right? And also 4 into 1. There's so many ways. And next is 6, 2 into 3, and 6 into 1. Is it not? So in that way, 4, 6 are your composite numbers. Make sense? So composite numbers include numbers which are not prime or 1. So all those are composite numbers. The next topic is prime factorization. So this is where we apply the prime factorization or prime numbers and all of those. So this question 147, I'll do it later. For now, I'll just do this 4 examples. So what is this prime factorization idea? When we write a number as a product of all its prime factors, it is called as prime factorization. When we write a number as a product of all its prime factors, it is called prime factorization. That is, if I write 6 as product of prime numbers, that is 2 into 3, this is known as prime factorization. Is 6 into 1 also prime factorization? Think about it. No, right? 6 is itself not a prime number. 1 is also not a prime number. This is not prime factorization. This is 8. Can you guess? Is this its prime factorization? Or is this the prime factorization? Or is this the prime factorization? And whichever you choose, you should also give a reason why the other, whatever you skipped, are not prime factorization of 8. Yes, this is the prime factorization. This is not. The reason being 4 is not a prime number. Not, as 1 and 8 are not prime numbers. Next is your 15. So this will be 15 into 1, 3 into 5. Right, these are the ways of writing 15. So in this, which is a prime factorization? You're right, 3 into 5 is your prime factorization. 17, we are in a weird situation. 17 can be written as 17 itself. There's no further prime factorization as such because these are prime numbers. So I've written a case wherein I'm talking about all the prime numbers and trying to find the prime factorization. So there's nothing. So 2, 5, 17 and 19. There is no prime factorizing it. Since it's prime number, there's no prime factorizing it. Right? So we'll see a few more numbers and try to find the prime numbers. Okay, we'll try to find its prime factor form. So we're going to start off with 30. Let's factorize and write in its prime factor form. That's the question. So we're going to start off with 30. So how to find the prime factor of 30? Well, write 30. Then since it's even number, you remember long division step kind of structure when we divide. So that's what we have to do over here. So 2 and 15, 2 and 5, right? Sorry, what am I writing? 3 and 5 are your long division method wala numbers. So here we are looking at writing 30 as what? 30 can be written as 2 into 3 into 5. Let me do few more example and make this process clear. So whenever you're doing any question, right, start looking at it in terms of what it can be divided with. So 49 odd number, not by 2, it can't be divided by 2, so we skip that. 3, 4 and 9, no, when we add it we get 13, so it's not divisible by 3, obviously not 4, 5, 6, and yes, at last we have 7. 7 7 is 49, and you end the prime factorization when you get a prime number. Okay, generally they tell do one more step, that is for kids, and you guys are not in that place anymore, so you can, this is all rough work, they won't give you marks for this. So till here is your prime factorization as of now. So I'm going to write 49 as 7 into 7. Then we have 70. So 70 can be written as, let's start with 2 because it's an even number. But my suggestion is 70 looks much easier to divide with 7 because it will get factorized to a very small number, simplify to a very small number, that is 10. And so it's better to start with whatever is convenient. For me 7 was convenient, for you guys 2 might be convenient, so it's your priority or preference. For me 7 was convenient, so I wrote that, and 10 is 2 into 5, you're done, right? So it is 7 into 2 into 5, but we should always write it in 2 into 5 into 7 in the ascending order. It helps in, well, it helps, you'll see that how it helps after some time. 76, it's an even number, so 2, 3 is a 6, 1 is a remainder, 8 is a 2, 1 is a 1 is a remainder, 9 is a 19 is a prime number. We can end over here, and we have 76, which can be written as 2 into 2 into 19. And next we have 147. 147 is not an even number, so certainly not divisible by 2. Is it divisible by 3? Well, 4 plus 1 is 5, 5 plus 7 is 12. So yes, it is divisible by 3. So 3, 4 3 is a 12, 2 is a remainder, 9 is a. So 49 we know, 7 7 is a 49. So 147 is 3 into 7 into 7 in its prime factor form. Simple examples, but still, let's not skip any. Just because we won't come back to all of this again, not at least directly like this. So let's finish it. 2, because it's an even number. 90, again an even number. 2, 45, divisible by 5. So 2, 9s are 3, 3s are. Right? Try to always do things which is much faster. Whenever you get obvious numbers that you can divide, just do that. Don't think too much. 180 can be written as 2 into 2 into 5 into 3 into 3. Again, good standard way of writing this is 2 into 2 into 3 into 3 into 5. And last we have 1092, which can be written as 1092. Since it's an even number, start with 2, 2 5s are 10, and 2 4s are 8, 1 is a remainder, 6 are 2 2s are 4, 1 is a remainder. Since it's an even number, I didn't even bother, just I wrote 2, that's it. 2 7s are 2, 3s are, and this is 273 is what? It's divisible by 3. So we have 3, 9s are 1s are, and 91, let's check with 2, obviously not, 3 not, because 9 plus 1 is 10, 4 not, 5 not, 6, so no, obviously. 7, let's try with 7, 7 1s are 7, 2 is a remainder, and we have your 13. So 13 is a prime number, so we end with 1092 being written as 2 into 2 into 3 into 7 into 13, and that is our answer. Okay, So I know it's easy. So let's move on to HCF and LCM and finish with that also. Take the test and start off with your next exercise as soon as possible.